Hello there, Wildcats. Welcome to your geometry class. In this video, we're going to discuss about right triangles and the Pythagorean theorem. So what is our objective for today? So our objective is we're going to prove Pythagorean theorem using similarity and establish the relationship in special right triangles. So our vocabulary is about Pythagorean theorem. One of the essential question here is how are similarity in right triangle and Pythagorean theorem related? Remember that your Pythagorean theorem and its converse describe how the side length of right triangle are related. So this is how this is the Pythagorean theorem that we have here. So if a triangle is a right triangle, then the sum of the squares of the length of the legs is equal to the square of the length of the hypotenuse. Then, okay, if triangle ABC is a right triangle, then a squared plus b squared is equal to c squared. Pythagorean theorem is not new to you guys. We have that as a discussion in your algebra 1. So let's just go deeper as part of your geometry, and we are going to relate Pythagorean theorem in similarity. Okay, so let's take a look at this one. So this is the theorem. So we'll be using this theorem in solving word problem, in solving problems or different problems that involves right triangle. Okay, so let's see. Our first problem here is to satisfy safety. So to satisfy safety regulation, the distance from the wall of the base of a ladder should be at least 1/4 the length of the ladder. Did Drew set up the ladder correctly? The floor and the wall are and the ladder form a right triangle. So as you can see, the distance of the ladder to the wall, it's 2.5 feet. Okay, and the height of the wall here until the end of the ladder, it's 9 feet. So first is we have to find the length of the ladder using Pythagorean theorem. So Pythagorean theorem, I'll just change the color here. So I'll use blue. So we know that Pythagorean theorem, as what I introduced a while ago, we have a squared, okay, plus b squared is equal to c squared. So you just plug in. So 2.5 squared for a, 2.5 squared plus b squared is 9. So 9 squared is equal to c squared. So 2.5 squared plus 9 squared, because 9 times 9 is 81. And then we have 2.5 squared. That is 2.5 times 2.5 will give us 87.25. Okay, is equal to c squared. So from here, we have to extract the root of both sides of our equation. When I say extract the root, you have to draw a square root, okay, so that we will have the value of c, okay. So c squared is 9.34 approximately. This is our c. Therefore, the length, okay, the length of the ladder is 9.34 feet. So I'll just put there feet. So the next step here is we are going to at least 1/4. It says there 1/4. So I'm going to find the 1/4 of the length of the ladder, which will give me 1/4 of c. Okay, 1/4 of the c is equivalent to 1/4 of the 9.34. Okay, What is the 9.34? That is the length of the ladder. The length of the ladder is 9.34. It's this one. So that is approximately that is 2.335. Okay, since, okay, I'll put here, since 2.5 is greater than 2.335, then Drew set up the ladder correctly. I'll repeat, since 2.5 is greater than 2.335, then Drew set up the ladder correctly. Okay, next problem. For letter B, the length of each cross piece of the fence is 10 feet. Why would a rancher build this fence with the measurements shown? So the number 6, 8, and 10. Okay, 6, 8, and 10. So it's 6, 8, and 10. Form a Pythagorean triple. So a Pythagorean triple is a set of 3 non-zero whole number that satisfies the equation a squared plus b squared is equal to c squared. Since 6 squared plus 8 squared is equal to 10 squared, the post, the ground, and the cross pieces from the right triangles. By using those measurements, the rancher knows that the fence posts are perpendicular to the ground, which stabilizes the fence. Okay, so one of the study tip that I'm going to give you is that we have to learn and recognize the common Pythagorean triples, such as 3, 4, and 5. Okay, and 5, 12, and 13 to speed the calculation, because 3 squared plus 4 squared is equal to 5 squared, because 3 times 3 is 9, 4 times 4 is 16, 16 plus 4 is equal to 25. So that is what we call now your Pythagorean triple. Same with 6 squared, that is 64. 6 times 6 is 36, and 8 squared is 64. So 64 plus 36 is equivalent to 100. So the rancher knows the measurement of the fence. So to give you here the theorem of special triangle, we have your 45, 45, and 90. So if we have that, then the measurement of your hypotenuse is your S times the square root of 2. Same with we have your 30 by 60, 90 special right triangle, that if you have that type of triangle, then the measurement of AC is equal to S times the square root of 3. And then AB is equal to twice as the side here. Okay, so for us to understand this further, these two theorems, we're going to apply it in an example. So in this example, apply special right triangle relationship. Letter A, Alejandro needs to make both the horizontal and vertical support AC and AB for a ramp. Is one 12-foot board long enough to for both support? Explain. Okay. Let's take a look at this one. So maybe we can use the 60-30. So we'll be using 60-30 on this case. We have one of the common error. I just saw it pops up in my head. One of the common errors is you have to be careful not to mix up the relationship of the shorter and the longer legs. Remember that the longer leg is measures the square root of 3 times as long as the shorter leg, so that the longer leg is between 1 and 1/2 and 2 times as long as the shorter leg. So in this example, we are using a special right triangle, which is your 60-30, 60-30-90 special triangle. Therefore, we can say that your BC, okay, BC is equal to twice as the measurement of AB, this one. So it's 10 feet. So it's twice as the measurement. And then your 10 here, which is your hypotenuse, that is twice as AB. So we just plug that in. So we divide both sides by 2. Therefore, your AB is 5 feet. So it's 5 feet. AB is 5 feet. Now we go to AC. So we said that AC is AB times the square root of 3, which is your AC is equal to your AB is 5, the square root of 3. Therefore, this will be your AC, 5 times the square root of 3. As that said, we can now find the length of the support. So to find the length of the support, I'll change color here. So to find the length of the support, we can say that AB plus AC is equal now to 5 plus 5 square root of 5 square root of 3. That will give us approximately 16, or no, just erase that. So it must be 13, sorry, 13.66 feet. Since, okay, since, I'll just put there, since 13.66 is greater than 12, the 12-foot board will not be long enough for Alejandra to make both support. So yeah, it's the 12-foot board is not long enough for the support. Okay, that's the rationale there. The next example, we have Olivia starts an origami paper crane by making the 200 millimeter diagonal fold. What are the side length and the area of the paper square? When we say origami, this is a paper folding. It's an art from Japan. Okay, so step 1 is we have to find the length of the side of the paper. So this is a special triangle, which is 45 and 45, and we have the side there. So we can say that S times the square root of 2, okay, is equal to 200. Thus, we have to divide both sides by square root of 2. So we have S is equal to 200 over the square root of 2. Okay, that is approximately S, using your calculator, guys, S is equal to 141.4 millimeter. Okay, that's step 1. Step 2 is we have to find the area of the square. Okay, area of the paper square. So what is the area of the paper square? That is equivalent to S squared. Okay, so the area now of that square is equal to the square root of or 100, the square root of 2, okay, squared. So we can now say that the area of the square, using our calculators, that's 20,000 millimeter squared, because you're looking at the area right now. So the paper square has a side length of 141.4 millimeter, and the area is 20,000 millimeter. All right, the concept summary of the Pythagorean theorem in special right triangles. So we have first we have the Pythagorean theorem and then the converse of Pythagorean theorem. And we also discuss about the 45, 45, 90 triangle theorem and 30, 60, 90 triangle theorem. Now, if you have any problem, guys, just email me and go over and watch the video over and over again. You will understand. So, we can practice more. Thank you, guys, and we'll see you in the next video. Bye-bye.